Okay, so we are recording.
Presentation. You know what? Maybe close out the presenter layout.
Oh yeah, we're um oh
So just hit the X on presenter layout. We're gonna check that it's recording or we'll start.
all right, yeah, we're recording. All right. So my name is Mitchell Bennett. I'm here to present my thesis project called Tourette Syndrome. First, I'd like to thank Dr. Fuser for advising me, Dr. Toms for taking the time out of your day to be here. Yeah, so here's the agenda. First, we'll talk about why you should care, then the objectives, contributions, backgrounds, methods, challenges, results, conclusions, and the future work, and then I'll take questions. So yeah, why you should care. First, let me talk a little bit about Tourette syndrome. Tourette syndrome, or TS for short, is a neurological disorder that may cause sudden, unwanted, and uncontrolled rapid and repeated movements or vocal sounds called tics. TS is one of a group of disorders of the developing nervous system called tic disorders. The motor or vocal tics of TS come and go over time, varying in type, frequency, location, and severity. If you have tics, you cannot stop your body from having them. The first symptoms usually occur between the ages of 5 and 10, generally in the head and neck area. These may progress to include the muscles in the torso, arms, and legs. Motor tics generally occur before the development of vocal tics. Tourette syndrome affects more boys than girls. Approximately 1.4 million people in the US have Tourette syndrome. Most people with TS experience their worst tic symptoms in their early teens, but tics typically lessen and become controlled by the late teens to early 20s. For some people, TS can be a chronic condition with symptoms that last into adulthood. In some cases, tics may worsen in adulthood. TS is not a degenerative condition, and individuals with TS have a normal life expectancy. Some common misconceptions about Tourette syndrome include everyone with Tourette's works out obscenities. Only 10 to 15 people with TS experience coprolalia, involuntary use of obscene or socially inappropriate words. People with Tourette's can control their tics if they want to. Tics are often involuntary movements and sounds. While some individuals can suppress tics temporarily, it requires immense effort and focus and is not a long-term solution. Tourette's is a mental illness. Tourette syndrome is a neurological condition resulting from brain dysfunction, not a mental illness. It is caused by a bad childhood. TS is not caused by psychological factors or parenting. It is a neurological disorder. All people with Tourette's have anger issues. TS itself does not make people more prone to anger, though co-occurring conditions like ADHD or anxiety may lead to increased emotional reactions to stress. Medication is the only treatment. Many people do not need medication. Treatments can include behavioral therapy or relaxation strategies, and medication is often reserved for severe cases. Tics are always obvious. Tics can be subtle and go unnoticed. Someone can have TS without having highly visible motor or vocal tics. The objective, so learning about Tourette's doesn't have to be this dry, and it shouldn't be either. While some may find learning facts from a book or speech engaging, most will not. This is why I wanted to make a project that can teach about this disorder that I've lived with for many years in a fun and engaging way. Using virtual reality, I was able to show the experience of having Tourette syndrome in a way that was not possible until fairly recently. So contributions. I found that trying to explain the experience doesn't always connect with people, and some people just don't really get it. So I wanted to contribute mainly to the ones with this disorder to help bring understanding to the ones in their lives. I don't want it to end there, though. This could be a great tool for medical professionals, such as researchers, psychiatrists, and therapists as well, or even anyone with a VR headset. So now I'm going to play this video while and this is the good word experience. Okay, so background. This project, I developed the experience using the Unity engine in C#, which is one of the leading platforms for VR development because of its strong XR tools, large asset ecosystem, and ability to deploy to multiple devices. Unity allowed me to quickly prototype interactions, test gameplay, and iterate on user experience. The project runs on the Meta Quest 2, which is a standalone VR headset. Unlike PC VR headsets that rely on a powerful graphics card, Quest 2 uses mobile-level Android hardware, specifically the Qualcomm Snapdragon XR2 chipset. This means it operates within much stricter performance limits. The hardware must handle all rendering, processing, tracking, and audio natively inside the headset, while also maintaining very high frame rates for comfort. The hardware context heavily shaped the project. Each decision, from lighting and textures to animations and physics, had to be made with the understanding that the system has a limited GPU budget, limited thermal tolerance, and no external tool. VR development on Quest is essentially a balance between creativity and efficiency. You want engaging interactions, but everything has to be optimized enough to run smoothly on mobile hardware. The nature of VR also has complexity. Head and hand tracking must be precise. The UI must be readable in a three-dimensional environment, and interactions must feel natural while remaining computationally inexpensive. Because the project includes multiple activities, each with unique mechanics and environments, I had to design them not only be fun, but also stay within a tight performance budget. So the VR performance considerations. Performance is one of the most critical aspects of VR development, especially on standalone hardware. Unlike traditional pre-games, VR requires consistently high frame rates, typically 72, 80, or 90 frames per second, depending upon the mode, because any stutter or drop can lead to discomfort or motion sickness. Even small dips in performance can break mood. There are several reasons VR is more demanding than traditional games. VR renders two separate images, one for each eye, effectively doubling the GPU workload. Maintaining 72 to 90 frames per second requires far more optimization than a standard console or PC game running at 30 or 60 FPS. Head and controller tracking must update with extremely low latency. The Quest 2 is battery powered and passively cooled, so heavy scenes can cause thermal throttling, which reduces performance over time. To meet these challenges, I have to carefully manage almost every aspect of the project. For lighting, I relied on baked lighting, which pre-calculates lights and shadows. I avoided real-time lights and shadows except where absolutely necessary. Mobile optimized shaders were used to reduce GPU workload. With geometry enhancing complexity, models were simplified to keep polygon count low. I used LED or level detail systems so distant objects automatically switch to lower resolution versions. Unnecessary background elements were removed or simplified. For culling rendering techniques, custom culling ensures Unity only renders what's in the player's field of view. The Gaussian culling prevents rendering of objects hidden behind walls or other geometry. Transparent materials were minimized because they are expensive to render. Scripting and game logic. I avoided heavy update loops and used event-driven logic where possible. Physics calculations were reduced or simplified for activities that didn't require full simulation. All these optimizations were essential to keep the experience smooth, comfortable, and stable across all activities. Goal is not to make the game run. It has to run consistently at the required frame rate to preserve immersion, prevent discomfort for the player. The project consisted of 5 activities or mini games, with a tick suppression mini game running throughout. There's rock jumping, quick we've already. Yeah, we are. This activity focuses on locomotion and environmental interaction. The player jumps from rock to rock in an uneven environment, which requires precision collision detection so the player lands cleanly on each rock without sliding or clipping. Custom movement logic to ensure that jumps feel controlled and comfortable in VR. Lightweight environmental assets, since large outdoor scene can be expensive to render on requested. Simplified shaders and textures to keep the GPU low. To avoid performance spikes, pick up the raw models low poly, bake the lighting, and use minimal particle effects. Now the shooting target activity. This activity involves shooting targets that appear in randomized positions around the player. Technically, this activity required randomized spawning watching the spawn zones that avoid unreachable or uncomfortable angles in VR. The challenge here is balancing speed and visibility. Targets needed to spawn quickly, but without overwhelming the headset CPU budgeting. Now the driving activity, which is happening right now. The key technical elements include a physics-based vehicle controller optimized for mobile VR, trigger-based time bonuses which activate UI updates with minimal overhead, smooth camera stabilization since VR can be sensitive to fast motion because rapid movement can drop frame rates. I simplified the track geometry and baked the lighting. Now the house exploring activity, which is next. In this activity, the player explores a home environment to search for specific objects. The technical focus was on spatial layout optimization so the house feels full without using too many high resolution assets. Interactive object strips that detect grabs, less friendly lighting, big lighting to reduce the GPU usage. Culling, ensuring the objects far away aren't rendered unnecessarily. Because VR players are close to objects, textures had to be clear but still lightweight to fit requests memory limits. The library book retrieval activity, which will be next. The library activity requires the player to pick up books and bring them to the front desk. The technical details included XR grab interactions for natural intuitive object manipulation, collision-based detection to confirm when a book reaches the correct location, object resetting object in case a player drops or throws the book across the room. Low poly shelving and book models, so library has many duplicate objects, all visible at once. To avoid performance issues, I use repeated meshes and instancing where possible, keeping geometry and textures consistent across the scene. The core experience revolves around a tick suppression mechanic that stays active throughout every activity. And the mechanic represents the constant, unpredictable nature of tick management. From a technical perspective, it was one of the most complex systems in the project because it had to run reliable on top of each activity without interrupting performance or user interaction. It works by every 1 to 20 seconds. A script triggers a new tick suppression prompt. This timing window is randomized rather than fixed to simulate the unpredictability of real ticks. When the prompt activates, a UI pop-up appears in the player's field of view. A specific controller button is displayed. The player must press the matching button quickly to successfully suppress the tick. Behind the scenes, a cooldown timer, random interval generator, and UI controller all run simultaneously, but the code is optimized to avoid expensive updates that would hurt VR performance. The system uses Unity's input system to detect the exact button press. This required mapping the press buttons to the UI prompts, ensuring that input checks were lightweight enough to run during every activity, preventing repeated prompts or accidental double registrations. This responsiveness was crucial. The mechanic needed to feel fast, fair, and consistent in VR. Consequences of missing or pressing the wrong button, or if the player presses the wrong input or takes too long. So history. Each activity has its own set of unique ticks that fit each of the activities. For example, in the rock jumping activity, a tick might cause an involuntary step or head movement. The shooting activity might shift in unexpectedly. During driving, a tick might briefly influence camera angle. In the house, the player might drop the object or look away. In the library, the player might fumble away. These ticks are implemented using small physical forces, camera adjustments, or scripted behaviors, all carefully balanced so they feel disruptive but not overwhelming or unsafe for VR comfort. Now, for some of the challenges, by far the biggest challenge was performance. Rendering and hardware constraints was a huge challenge. The Quest 2 must render to high resolution frames at 72 to 90 FPS, which doubles the GPU workload. Large environments risk exceeding the mobile GPU budget. Any frame drops can cause discomfort or motion sickness in VR. So the solutions were to use baked lighting, simple shaders, and mobile-friendly materials, propulsion and fuss and cooling to limit what is rendered, and reducing the texture sizes and polygon count across the whole scene. So that animation and movement and player comfort was another big challenge. So fast moving in VR, like the driving, can cause motion sickness if not handled correctly. Tick effects must trigger quickly, but also not cause motion sickness. Large environments with multiple moving elements can lead to frame swings. The solutions for that were to smooth camera movement and limited focus, forced camera motions, using lightweight tick animations and subtle forces instead of heavy physics, and keeping the NPCs, moving objects, and background animations minimal. The tick suppression system was kind of challenging, required a lot of trial and error. It has to run consistently across every activity. The randomized prompts have to feel responsive, but not like within the context of the project. The tick effects must trigger without blocking the gameplay or slowing down the headset. The solution was to use event-based logic with no heavy update loops. The tick effects were designed to be simple, quick, and optimized. The memory and asset management is another big challenge. Big textures and too many mesh triangles can quickly exceed the Quest's limited memory. Too many unique textures and materials increase VR usage. Memory fragmentation is also a common risk in VR. And for solutions, you reused materials and prefabs, kept textures small, and used balancing where possible, reduced unique asset variety to maintain memory stability. The entire project required tight optimization on every level, rendering, physics, interactions, animations, asset management by simplifying models, baked lighting, using event-driven logic, minimizing active objects, and aggressively pulling unseen elements, and maintain smooth and comfortable performance across all activities and kept the experience stable and then optimized less. Since this was my first time developing for VR and my first time using the outside interaction toolkit, major part of the project involved learning entirely new workflows, tools, and design principles. This created its own set of challenges, both technical and user experience related. So understanding the VR comfort and movement was a big challenge. So the VR requires different comfort standards compared to traditional games. Movement that feels normal, flat screen can cause nausea in VR. I had to learn about headlocked UI, motion rules, and how to avoid motion sickness. And some solutions were to use smooth camera motion and avoid forcing player view movement. And just adopting VR conventions such as fixed UI positions, reduce sudden camera shifts, and careful movement speeds. So learning the XR interaction toolkit took me a little bit of time. There's interactables, gravel objects, ray interactor settings, and action-based input settings were all new to me. Getting hand controllers and object grabbing to feel natural required a lot of trial and error. Some interactions like dropping object, custom grab points, or preventing conflicts were not immediately intuitive. And so some solutions broke down the interactions in small chunks and tests. Customized XR grab interactables to match each minigame's needs. Use the action-based input system for consistent and reliable input detection. Debugging and testing in VR is a little bit different. So the challenges, VR debugging, it's a lot slower because you have to build and test on the headset frequently. Many normal debugging tools don't work the same way on your screen than inside the headset. And iterating small changes become time consuming. Solutions, I had to use the Oculus Link to test in real time the Unity editor. Added extra on-screen logs, sounds, and visual cues for debugging within the VR. Okay, so yeah, as a first-time VR developer using the XR interaction toolkit, the biggest challenges involve learning new interaction models, understanding VR player comfort, managing unique controller inputs, and creative interactions that feel natural in the headset. Through testing, simplifying systems, and adopting VR best practices, I built a solid foundation that made each minigame comfortable, intuitive, and stable in the class. Other challenges mainly consisted of just logic-based scripting issues and iterative debugging and a little help from LLMs was the way to solve those challenges. Okay, so results, what the project offered. So in the end, the project succeeded in creating a fully functioning VR experience that not only delivers 5 unique minigames, but also gives a good glimpse into the experience of having Tourette syndrome. Plus, the development, several major goals were achieved. A complete multi-game VR experience has successfully built 5 fully interactive mini-games or activities, each with its own set of mechanics and environments. There was rock jumping, target shooting, driving, house searching, and library both retrieval. Each one runs smoothly on the MetaQuest 2 and provides a distinct gameplay challenge. There was a unified tick suppression system. One of the biggest accomplishments was creating the kind of the tick suppression mechanic that runs across the whole game. It randomly prompts the user every 120 seconds to test specific button inputs, triggers unique ticks per activity, and yeah, it adds constant unpredictable pressure during gameplay. And the mechanic successfully simulates the challenge of managing ticks while performing the everyday tasks. It's fully optimized on VR for performance. The project maintains stable VR performance despite having multiple environments, physics systems, interaction types. Key success points were smooth frame rate, low poly, optimized models, baked lighting, event-driven input, and tick logic and hold. As a result, the experience stays comfortable and responsive in VR, even with the added tick system running in the background. Yeah, functional and natural VR interactions. As a first-time VR developer, I implemented a range of VR interactions systems using the XR interaction toolkit. That include grabbing and manipulating objects, shooting, driving, navigating environments with VR-friendly movement, using UI that appears clearly within VR space and interactions that feel intuitive and consistent across all activities, and realistic simulation of tick interference. Project successfully conveys how ticks can interrupt or complicate each task. Players experience sudden viewpoint shifts, drop items in descriptions, movement disturbances, and more. These effects illustrate the everyday challenges faced by people with tick disorders in a safe, controlled VR environment. Now, for future work, although the project delivered a complete and functional VR experience, there are several opportunities for expansion and refinement. These improvements would not only enhance the user experience, but also open the door for broader distribution and real-world impacts. A big next step would be to add more activities and more ticks to the experience, which can include classroom or workplace tasks, sports or coordination-based games, or more time-constrained or multitasking challenges. Expanding the range of activities would create a more comprehensive representation of how ticks interfere with different tasks, different types of tasks. Another next step would be to upgrade all the 3D models and textures, improve the environments and the lighting, and adding more realistic animations and refining sound design with haptics. This would make the project feel more immersive and professional while still maintaining strong performance on mobile VR hardware. Another major goal is to get the project on the MetaQuest store or the App Lab, which would involve meeting Meta's technical guidelines, conducting performance and comfort testing, adding accessibility and calibration options, creating proper menus, onboarding, and tutorial flow. Store release will make the project publicly accessible on a major VR platform. And then the last one, we call if distribution through the Tourette Association of America. Another key direction would be to partner with the Tourette Association of America to distribute the experience for educational or outreach purposes. And this can include showcasing the project at events or conferences, sharing it with educators, clinicians, and families, using it as an empathy building tool, or supporting awareness campaigns with an interactive VR component. This would help the project reach people who would benefit most from the experiencing a realistic simulation of challenges that come with having Tourette. Overall, the next steps focuses on expanding content, enhancing quality, refining interactions, and bringing the project to a wider audience through a formal distribution channel. Okay. All right. So that's it. I will go to the question. Also, I have the demo if anyone wants to try it.
So I understand the objective is to simulate it.
Yes.
Is it also useful for those with Tourette's? Does it kind of mitigate anything or no?
No, I don't think so. Well,
Because I attended lectures on VM like brain computer interfaces.
Yeah.
Where for epilepsy, they've got impulses, they send in a chip that sends impulses when they detect an epileptic seizure or something. Is there something similar for Tourette's? Do they have that where it prompts? Because I can see like not necessarily VR, but more AR, like glasses that can trigger prompts so that you're distracted, I think, and they can control it better.
That might, that might be a thing.
Yeah.
I haven't looked into that.
It's all new to me, very
Yeah,
interesting.
yeah.
Thanks for that.
Yeah.
And I know working with VR is not easy.
It has its set of challenges.
Yeah. The performance especially. So, how did the scripts how the scripts integrate with, like, where were the scripts running from? They running in the cloud that connects
No, it's
Right.
all on the hardware.
within all of them.
Yeah.
So in the app itself.
Yeah, I actually am glad because about 3/4 of the way through, I decided to build it to that. And then I realized that I wasn't really thinking too much about performance. And when I built to that, it was a huge mess.
Yes.
So I had to like do a lot of work to get.
Do you think a
performance.
cloud like script might perform better rather than the script running on the hardware?
It would, I don't know. I haven't heard of that.
Like, what type of script was it that would create such performance issues?
So
What it looked like?
the main performance issues were coming from the textures and the models. The textures, some of them were just too big. And then the models had just too many polygons, many triangles. And then also, actually, I had to scrap one activity because I had a lot of animations running, and that just totally tanked the kind of the frame rate. So yeah, that's where you, especially with animations, you kind of have to disable all the animations unless you're like pretty close to the object. Yeah, it was the scripts, it was mainly disabling and re-enabling things as kind of you get close to them. And then also, I didn't really experience too much interference with like kind of heavy update methods. But from my research, it seemed like a lot of people were having a lot of issues with that. So I didn't have to do too much to kind of modify my stuff, but I did like simplify it. Like for using event-based interactions can really kind of lower the reliance on like update loops. So I had to change a few things to be more event-based than within the actual update loop. Does that make sense?
Yeah, no, it makes sense.
So first of all, thank you for your presentation. That's the first time I've got to see the whole game played all the way through, which was kind of cool.
Yeah.
There's a lot of changes since I like saw the gameplay of each section, so I can tell that you put a lot of work to polishing it out.
Yeah.
Can you give examples of that event-driven logic and spell that out a little more clearly?
Sure.
Like some concrete examples from the game where you wrote the logic and what it looked like to have to write that logic?
Yeah, so basically in Unity, you make kind of listeners for certain things, button interactions, or you can, like a certain button, you can map that to like a certain script. Yeah, but then also if you want to have something else happen, like only sometimes you can trigger it by using like the event logic from the button and then kind of add to it, like if this gets triggered, then do this. So it was a lot of that. There's also kind of like environmental triggers that are event-based, where it's like when you walk into a certain area, it would get triggered instead of like looking for it within like an update loop. So those are the two main methods.
Okay, and then another like technical thing that I wondered about, so you talked about real-time lighting versus pre-rendered lighting. As soon as you said that, I started looking for where I could see like pre-rendered light, some real-time lighting. Was the book one of the examples of the real-time lighting where you grab the book, it seemed like it like lit up your hands?
No, that was
No.
that was
Okay, so what were some examples? Were there any areas you had to do real-time lighting?
I did think about doing that, but then I kind of saw that they should avoid that, so I didn't kind of mess with that. It's-
Okay, now taking a step back from the technical to more like big picture.
Yeah.
Do you have any ideas? You mentioned you're thinking about putting this on the store. How plausible is that? Like, how much work is left if you were gonna try to put it on the store? Like, could you estimate like how many hours of work it would take to get it to the store
Yeah, so there's.
or money? I don't know what's
If
involved.
you're familiar with, there's SideQuest is another installing platform where, because the MetaQuest store is notorious for denying people and being difficult to get on. So a lot of people use SideQuest. And I'm actually pending for go on
Okay.
SideQuest right now. It'll probably go up there. I think I saw that the MetaQuest has early access. So I'm just gonna go with it and submit an or submit the project like
Okay,
pretty much now for early access review. I'm not sure if it'll get approved. But if it does, then that's great. And then I could kind of update it as I do more stuff.
all right, this next question is totally like coming from left field, I'm sure, but you ported it once. If you port it again, like what happens if this takes off in the Tourette's community, but not many people have,
Yeah.
you know, VR headset, like how much would it break your system to try to put it on a laptop? You know what I'm saying?
Yeah,
Like obviously a lot of it's based on VR manipulation.
right.
It'd be kind of cool, right?
It
Or what do you think?
kind of, it wouldn't be too, but I'm trying to think.
It's easy to do, but you have to need the immersive
Right.
Yeah,
experience. I spend a lot of time in VR, so and to see how watching the video and see how the prompts would
Yeah,
I can't see it translating well to a phone or
right.
a laptop or tablet or something.
Yeah.
But you couldn't suppose.
Yeah,
Just
it's true. Like a lot of
getting the experience
the
back.
whole experience is like you walk up to the panel and read it, right?
Yeah.
Yeah.
But also the triggers, right? Because you're supposed to kind of go through what someone with Tourette's would, you have it 20 seconds, but random will kind of feel based on environment or what the condition is. So laptop, I think I don't know, I think the immersive nature of is lost.
Yeah. So maybe it's a question of not worth the effort.
Well, I think you can. I don't know, like there's a simulator, I'm sure.